Hello everyone, welcome to Coders Camp. We are at 17th day of December LeetCode challenge and the problem we are going to cover in this video is maximal square. So the input given here is a n cross m matrix with all zeros and ones as values, and we have to return the largest square which contains only ones, and we have to return the area. So let's understand this with an example. So here is the given n cross m matrix with values zeros and 1 given in the problem statement, and we have to return the area of largest square with all ones. So now we have to figure out all one square from the given matrix and return the maximum one. So let's start by having the very first one we encounter in the very first row. Starting from here, if you see, there is a 1 going till row 4. So 1 2 3 4 ones are there. So let's check whether we can form that largest one in the other side as well. So if you see, there are only 3 ones, but the last one is 0. So in this case you cannot form a 4 cross 4 square. So in that case, let us try for a 3 cross 3 square. So now let's stop it here and stop it here as well and make it as a square, and let's see whether all the values inside the square are 1. Yes, it is all 1. So if you area is nothing but addition of all these numbers. So, or if it is a 3 cross 3, then 3 cross 3 is equal to 9 is the area. So we have found one square whose area is 9. So let's see what are the other squares we can figure out. In this case, this also is having smaller squares inside it, but since we have found the maximum one, we don't have to really worry about the smaller ones. So let's see what are the other squares we can form. So if you see towards end, you can again form only a 3 cross 3 here as well. And again, there are smaller squares inside these squares, so but still we don't have to really worry about them as we have found the larger ones. So finally, all we could find the maximum one here is of value 9. So that is going to be our output. So how are we going to approach this? So if we are approaching this via a brute force way, then you have to first iterate the given array, and whenever you find a 1, then you have to extend its area to however one it finds across the row and column, and also have to check all the values within the range or 1 and then calculate the square, and similarly you have to approach with all the ones and finally come up with the answer. So this is going to work in big O of m into n square time complexity. So how do we solve it in an optimal way? If you remember, we have solved the maximum value of a rectangle in a given matrix. So which this problem is quite a simpler variant of that problem. So we have solved that using prefix sum and a DP. So here again, we are going to use the same approach. So let's see how we're going to do that. So now let us consider this as a DP array, which is going to store the side length of a square, which is nothing but the area of a square is equal to n cross n. So if you find one side length of a square, all whose value is 1, then you can easily find the area. So if suppose the square's length is 3, then 3 cross 3 is 9, and that is going to be our output. So we are going to store at each cell what would be the maximum side length of a square that we can form at this point. So as I always say, DP is nothing but solving each small sub problems and coming up with a bigger solution using those solutions of the sub problems. So let's start from the very first cell. So at the very first cell or any cell in the row or column, the values are going to be same because individually they all form a square. So however you calculate the square value you can get from those cells, they are going to be same. So let's fill our DP array with the same values as that of in the row and column. So we have filled our rows and columns. Now we are exactly at 1, 1 and checking whether what is the maximum square we could form at this point, or maximum side length of a square. So in this case, if you see, there is a 1 upwards and 1 rightwards, but the square must be 2 cross 2. So in this case, there is a 0 at the very first position. So at this point, you cannot form any squares. So the answer will be 0. So let's move on to our next position, which is 1, 2. So let's see at this point what is the maximum side length of a square we can form. So if you see row wise, there is 3 ones and we have only one upwards, which is only one row, which means we can maximum possibly form a 2 cross 2 square. So this one can't be considered. So let's see by forming a 2 cross 2 whether it can form a square. Yes. So it has all values as 1. So possibly you can form a 2 cross 2. So in this case, we have to update the side length of the square we have found. So what is the side length? Which is 2. So I'm going to update 2 here. So which is the maximum so far we have found. So here is the next one. So at this point, what is the maximum square you can form? So in this case, you have only one row up there. So the maximum you could form is 2 cross 2. So yes, it is possible because all the values are 1. So in this case, I'm going to update here 2 as well because that is the side length and the area will be 2 cross 2, which is 4. So coming to the next point, which is a 0. So you cannot form a square which is ending with 0. So in that case, this place is going to hold 0. And moving on to the next one, which is a 1. So in this case, you have only one column left to it, and that is also 0. So you cannot actually form a square which is ending with this number. So in this case, I'm going to update 0 here. Same goes with the 1 at the down, and same goes with the 0 at the down, because at this point we cannot form a square ending with 0 or having a value 0. So now coming back to all these ones area. So now I am right now at this 1, and what is the maximum we can form? You have one more 1 in the left side and 3 ones upwards, but since you have only one, the maximum you can form is going to be 2 cross 2. So I'm going to update the value 2 here. Coming to the next one. So in this case, if you observe, we have 3 ones before it and 3 ones left to it. So in this case, it is possible to form a 3 cross 3 square. Let's check the values around this square. So this 3 cross 3 is having all ones. So the side length of this square is going to be 3 and the area is going to be 3 cross 3, which is 9. So I'm going to update 3 here in this spot. Moving on to my next one. So if you see there is a 0 upwards, so here you cannot possibly form a square, but this is individually a square. So I'm going to update 1 here. So I think I made a mistake here. This cell also individually a square, so I can update 1 here as well. So let's come back to the one which is placed at 3, 3. Sorry, 2, 3. So what is the maximum length you can form? So if you observe, you can form a 2 cross 2 square. So I'm going to update the value as 2. So before filling all this value, if you observe how we are filling these values. So logically, we are seeing the length of the square and updating the values here in the DP. But there is a pattern these values follows to update themselves instead of checking the actual values of all ones in the table. So how to do that? We clearly know a square can be formed by considering ones at all direction. That is, if there is a square, then it must have ones towards left, also towards up, as well as diagonally. So if all are ones, then only we can form a square ending at that spot. So in this case, we have to look for all the values which are in 3 dimension or 3 direction. So if we are at this cell, then we have to look at the value upward, one cell up and one cell left and one cell diagonal. So we have to pick the minimum of these 3 values and do a +1 to update this position. Why we are doing that? Because we have been filling at every spot what is the maximum square side you can form. So from that spot you can pick, which means from that sub problem solution you can build your bigger solution. So for at every position we are picking the minimum value of these 3 positions and adding a 1. So consider here at this spot where we filled 3. So if you see, we are at this position, so we have to look for these 3 values, which is 2, 2, 2. So all are having a square of size 2. So in that case, diagonally you can add a 1 to form a square of length 3. If suppose we are at this position, so how possibly we could fill the value? We have to look for left value, which is 3, diagonal value, which is 2, but in up direction the value is 0. So until here you cannot form any square. So the only option you can fill here is that particular square itself as a area. So in that case, simply 0 plus 1 will be updated. So similar way, we are going to update the rest of the values in our DP table. So here, if you see which is the minimum value out of these three, 2 is the minimum value. So we are going to update 3. So here, the minimum of these three values is 1. So 1 plus 1 is going to be 2. And same way, minimum of these three is 0. So I'm going to update 1. So minimum of these three is 1. I'm going to update 2. And minimum of this 3 is 2. And I'm going to update 3. So you can cross verify it. For example, if we are at position 3, then you can look for this value and whether you can form a square of length 3 or not. Yes, you can actually form a square of length 3. Consider at this position, you can verify whether you can only form a square of length 1. Yes, we are exactly here, and if you check the value is 0, so you cannot form a square of any length, so you just simply updated 1 as the individual value. Again, similar to this position, if the value is 2, so if you see, you can only form a square of 2 comma 2, because if you extend your length over this side, you have 0. So yes, this is it. Simply we are going to pick the maximum value in the DP array, because these are the values which are nothing but the maximum square length you can form. So you have to pick the maximum value and do a maximum value into maximum value. For example, if the value you are picking is n, then our result must be n cross n. So here the maximum value is 3. So we have 3 3s, so all are same. So since the output is maximum area, we could, so we can pick the maximum value 3, and 3 cross 3 is going to be 9, and that is going to be our output. So before getting into the coding section, this algorithm will run in big O of m cross n time and space, because we are using a DP array to store the subproblem solutions, and we are going to traverse the given m cross n array to consider the values and add it. And we are also going to update a max value every time we update the DP value of the array, and that is going to be taking place in the same iteration we update the value. So yes, this is it. We are going to do the exact thing in the code. So let's get into the code now. So here is the code for this problem. As I said, we are going to declare a DP array to store the values. So before that, we are assigning the length of the row and column. So the length of the row is matrix.length clearly. So column is based on the row values. If suppose we have row less than 0, in that case, we cannot form a square. So there is no sense it is the column only is available. So in this case, if the row is greater than 0, then we are updating matrix.length. If not, we are updating 0 here. And we are forming the DP array and going to update the values. And also we are initializing the maximum square length is equal to 0, which is the max variable, which is going to take the maximum value out of the DP array after we update at every step. And finally, it is going to return max square length into max square length as our output. So here we are iterating with 2 for loops, and we are checking if the given matrix is having 1. So if there is a 1, then we are checking which is the minimum value, whether the left value or the up value or the diagonal value, and pick the minimum out of these three and do a plus 1. So every time we update the DP value, our max square length variable is also going to get updated with the maximum value so far in the DP. So hope I made some sense. So let's run the code. Yes, so let's submit. Yes, so solution has been accepted and runs in 6 milliseconds. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe, and let me know in comments. Thank you.